Today we will study the dependence of reaction rate on concentration, and the rate law expression. We will study these. We will find what is the effect of concentration on rate. Students, in the chemical reaction, reactants get converted into the products. So the concentration, we see that the concentration of reactants, then the reaction procedures, concentration of reactants decreases, and that of the products increases. Concentration of reactants decreases and that of the products increases. Now in the beginning, when the time is 0, only reactants are present. That means concentration of reactants is high. Concentration of reactants is high. I will show it graphically here. In the beginning, concentration of reactants is high. This is the concentration, and this is the time. In the beginning, concentration of reactants is high, so rate of change of concentration is high. I will show it graphically. This is the rate of change of concentration, and at the beginning, when the time is 0, concentration of reactants is high. That means rate of change of concentration is high, and with the passage of time, products get formed. So this is the product. So products get increased. Concentration of reactants decreases with time, and concentration of products increases with time. So at the initial stage, rate of reaction is high. At initial stage, rate of reaction is high and decreases with time. This indicates that rate is proportional to the concentration. This indicates that rate depends upon the concentration. There was a quantitative relationship between rate of the reaction and concentration, was given by Goldberg and Waage. That is known as law of mass action, which states that rate at a given temperature rate is proportional to molar concentration of reactants. At a given temperature, rate of reaction is proportional to the molar concentration of reactants. I will write a reaction A, for example, a hypothetical reaction A plus B gives products. Therefore, as per the law, rate is proportional to, I will write in A in the square brackets. Product of square brackets indicate that this is the molar concentration. We call it active mass. Square brackets indicate active mass, that is molar concentration. So rate is proportional to the product of molar concentration of A and product of molar concentration of B. A and B are reactants. So rate is equal to K into A into molar concentration of B. K is the constant of proportionality. called rate constant. It is called a rate constant. K is called rate constant. K is also called velocity constant. It is called specific rate constant. K is a constant of proportionality. It is called rate constant. It's called velocity constant. It's called specific rate constant. Now, if rate is equal to K concentration of A into concentration of B, if concentration of A and B is unity, that if K concentration of A into 1, that is rate is equal to K. So velocity constant is defined as rate of reaction when concentration of reactants is unity. So velocity constant, sometimes it is asked in the examination, what is velocity constant? Velocity constant is defined as the rate of reaction when the concentration of reactants is unity. Characteristics of velocity constant. Velocity constant. Number first, it is the measure of velocity constant is the measure of rate of reaction. That means if large is the value of K, faster is the reaction. Smaller the value of K, slower is the reaction. That is why we call it is the measure of rate of reaction. Number second, different reactions have different velocity constants. That is, each reaction have its own velocity constant at a fixed temperature. Number third, at fixed temperature, value of K is constant. And changes with temperature. Number third, velocity constant is independent of concentration. Velocity constant is independent of concentration of reactants. It depends upon the nature of the reactants. Velocity constant is independent of the concentration of the reactants. It depends upon the nature. This was the characteristics of the reaction. Now, units of characteristics of velocity constant. Now we will study it. Now the units of rate constant. Units of rate constant depend upon order. Units of velocity constant depend upon the order of the reaction. I will again repeat it. Velocity constant की characteristics क्या है? It is the measure of rate of reaction. Number first, large the value of K, faster is the reaction. Smaller the value of K, slower is the reaction. Different reactions have different velocity constant. At fixed temperature, value of K is constant and changes with temperature. Velocity constant is independent of the concentration of the reactants. It depends upon the nature of the reactants. Units of K, that is units of velocity constant, depends upon the order of the reaction. Now, in order to find actual dependence of rate, actual dependence of concentration of reactants, that is, in order to find the actual dependence of concentration of the reactants, it is essential to carry experiment essential to find or to determine experimentally the actual dependence of the concentration. For example, in order to find the actual dependence of the concentration of reactant, it is essential to carry the experiments to find actual dependence. हमें एक्सपेरिमेंट करना कि किस कंसंट्रेशन टर्म पर रेट डिपेंड होती है. फॉर एग्जांपल, आई विल राइट रिएक्शन twice NO2 plus F2 gives twice NO2F. Experimentally, it has been found that rate is proportional, rate is dependence is equal to NO2 concentration of F2. Rate is proportional to the concentration of concentration of NO2 and product of concentration of NO2 and F2, not NO2 raised to power 2. This equation is rate law expression because it has been found experimentally. This is the rate law expression. Similarly, if you write twice N2O5 decomposition of dinitrogen pentoxide, it gives 4 times NO2 plus O2. Rate is proportional to experiment. It has been found rate is depends upon concentration of N2O5, not N2O5 raised to power 2. This is experimentally defined my rate. Now this is the rate law expression. For example, if I write a reaction A times A plus B times B plus C times C gives products rate is equal to A concentration of X, B raised to power Y, C raised to power Z. These X, Y, Z are the concentration terms. These are determined experimentally. So this is the rate law expression. So rate law expression. What is rate law expression? It is a mathematical expression which denotes rate of reaction in terms of molar concentration of reactants with each term with each raised to a power which may or may not be equal to stoichiometric coefficients. These coefficients are determined experimentally. This is the rate law expression. I will repeat it. Rate law expression is a mathematical expression which denotes rate of reaction in terms of molar concentration of reactants with each raised to a power which may or may not be equal to the stoichiometric coefficients. These powers are determined experimentally. This is the rate law expression.